For the physics extra credit, I did Chapter 2, Problem 53, which reads, setting a world record in a 100-meter race, Maggie and Judy crossed the finish line in a dead heat, both taking 10.2 seconds. Accelerating uniformly, Maggie took 2 seconds and Judy took 3 seconds to attain maximum speed, which they maintained for the rest of the race. A. What was the acceleration of each sprinter? B. What were their respective maximum speeds? And C. Which sprinter was ahead at the 6-second mark, and by how much? So for this problem, the knowns are that it's in a 100-meter race. It takes 10.2 seconds. Maggie's accelerating for 2 seconds, and Judy's accelerating for 3 seconds. So for A, I let Maggie's acceleration be A subscript m. Then I used v final is equal to v initial plus acceleration times time in order to find Maggie's acceleration when she stops accelerating. So I did this by doing v of Maggie when she stops accelerating is equal to 0, which is her initial velocity, plus her acceleration times 2, which is equal to 2 times her acceleration. Then I use the formula x is equal to x initial plus velocity times time plus 1/2 at squared in order to find the distance she travels when she's accelerating and when she's not accelerating. So for when she's accelerating, I did the initial position as 0, the initial velocity as 0, and then her acceleration is also a subscript m, which we stated here, and her time is 2 seconds for the 2 seconds which she is accelerating. So this is equal to 2 times her acceleration. Then when she's not accelerating, I also did her initial displacement as 0, and her initial velocity is the velocity that we computed earlier, and then multiplied by the time which she is not accelerating, plus 1/2 times her acceleration, which is 0, times the time squared. So this is equal to her velocity times the time which is the remainder of the period. So this is equal to 2 times a subscript m, which we calculated here, times the total time minus her acceleration time, which is the time that she is not accelerating. So this is equal to 2 times her acceleration times 8.2, which is equal to 16.4 times her acceleration. Then I found that her total distance is equal to the distance which she is accelerating plus the distance which she is not accelerating. So it's equal to 2 times her acceleration plus 16.4 times her acceleration, which is equal to 18.4 times her acceleration. Also, this total distance must be equal to 100 meters, which was one of the givens. So dividing both sides by 18.4, we get her acceleration as 5.43 meters per second squared. For Judy, we took a similar approach. We again used v final is equal to v initial plus acceleration times time, where the initial velocity is 0, her acceleration, and she's accelerating for 3 seconds. So it's equal to 3 times her acceleration. Then I once again use the formula x is equal to x initial plus velocity times time plus 1/2 at squared. Again, for the portion where she is not accelerating, her initial displacement is 0, her initial velocity is 0, her acceleration is a subscript j, and she's doing this for 3 seconds. So this distance which she is accelerating is equal to 4.5 times her acceleration. Then when she's not accelerating, her initial displacement I also said was 0. She's traveling at v subscript j, which is the velocity when she stops accelerating, and that's for the remainder of the period. And the acceleration is 0 for this time because she's going at constant velocity. So this is equal to her velocity times the remainder of the race, which is equal to 3 times her acceleration, which we calculated up here, times 10.2 minus 3, which is the total time minus the time which she is accelerating. So this is equal to 21.6 times her acceleration. Then for her total distance, it's equal to the distance which she is accelerating plus the distance which she is not accelerating. So it's equal to 4.5 times her acceleration, which we calculated up here, plus 21.6 times her acceleration, which we calculated here. So this is equal to 26.1 times her acceleration. And once again, this must be equal to 100 meters. So dividing both sides by 26.1, we get her acceleration is equal to 3.83 meters per second squared. For B, we have to calculate their maximum velocity. So because their velocity is constant for the remainder of the race after they stop accelerating, we could just calculate the velocity once they stop accelerating. So by doing this, I get the velocity of Maggie is equal to her acceleration times the time which she is accelerating, which is equal to 5.43 times 2, which is 10.9 meters per second. So this means that she'll be going at 10.9 meters per second for the remainder of the race after she stops accelerating. Similarly, the velocity of Judy is equal to her acceleration times the time which she is accelerating, which is equal to 3.83 meters per second squared times 3 seconds, which is equal to 11.5 meters per second. So to solve C, I found the distance of each person at the 6-second mark. And I did this by finding the distance they travel while accelerating and while going at a constant speed. So while Maggie's accelerating, I used the formula we previously gotten, which is equal to 2 times her acceleration. So which would be 2 times 5.43, which is 10.9 meters. Then when she's not accelerating, I use the formula we previously gotten. However, instead of using 10.2 seconds this time, I use 6 seconds because they only go for 6 seconds instead of 10.2. So calculating this, I get 8 times her acceleration, which would be 8 times 5.43, which is equal to 43.4 meters. So adding these, I get her total distance at the 6-second mark to be 54.3 meters. Similarly for Judy, I calculated the distance she travels while accelerating, which is equal to 4.5 times her acceleration. So 4.5 times 3.83 meters per second squared, which is equal to 17.2 meters. Then for the distance she travels while not accelerating, that's equal to 3 times her acceleration times 6 seconds minus 3 seconds. So this is the same equation we used up here. However, instead of 10.2, we use 6 seconds, just how we did it with Maggie, because we're trying to find it at the 6-second mark instead of after 10.2 seconds. As a result, this is equal to 9 times her acceleration, which is 9 times 3.83, which is equal to 34.5 meters. Then I once again added these to get her total distance to be 51.7 meters. So as a result, because Maggie's total distance is greater than Judy's, Maggie is ahead, and she's ahead by 54.3 minus 51.7, so 2.6 meters.